Welcome to Life Changer Tutorials. In this very video, we are going to be looking at probability in preparation towards your Waec exams. Probability is the likelihood of something happening. That's the chance something is going to happen. But mathematically, probability is the ratio of the outcomes, of the number of outcomes to the total number of possible outcomes. So, probability of an event is equal to the number of the event or number of outcomes all over the total number of possible outcomes. Okay, now we're going to look at an example or some example to explain that definition. Here we have in a class of 5 boys and 6 girls, a student is picked at random. What is the probability that the student picked is a girl? Okay. In the class, first of all, we have the sample space. Your S there means the sample space, which signifies the total number of outcomes. And we have 5 boys and 6 girls. So 5 plus 6, which is equal to 11. So the total number of outcomes is 11, which is 5 plus 6. Now, but we want to look for the probability of picking a boy, okay? We are given that boys, B, is equal to 5. Then G, girls, is equal to 6. So the probability of picking a girl, which is PG will be equal to the total number of girls, which is 6, all over the total number, which is 11. So the answer in this case is 6 over 11. Now let's see another question. A total of 100 women patronized a supermarket in a day. Each woman bought either of mango or apple. If 60 bought mango and 40 bought apple, so we can say mango is 60, apple is 40. Or you say number of mango, the number of apple, okay? Now, if 60 bought mango and 40 bought apple, and the management of the supermarket wanted to give a discount to a particular buyer, what is the probability that the buyer bought a mango? Now, first of all, we have to know the total number. So the total number altogether is 100 according to the question. Now, the probability that the person picked bought apple, PA, is equal to the number of apple, which is 40, all over the total number, all the number, which is 100. Then also the probability, and 40 over 100 here means 2 over 5. Then the probability that the person picked bought mango will be, the total mango is 60, so 60 over 100, and 60 over 100 is 3 over 5. Okay, let's see another example. Sometimes questions can be asked in terms of table. You can be given a table like this one. The table below shows the number of children per family in a community. So we give number of children, we have number of children, we have number of families. So this means 3 families have no children, 5 families have just 1, 7 families have 2 children, and so on and so forth, okay? So the question now is, what is the probability? The first question, what is the probability that a family has 3 children? What is the probability that a family has 3 children? Okay. Now, but the first thing is that we are to add the total number of families. Let's know the total number of families, which gives us a sample space. So the total number of families is 3 plus 5 plus 7 plus 4 plus 3 plus 2. And 3 plus 5 is 8. 8 plus 7, 15, 19, 22, 24. Let's do that again. This is 8, this is 15, this is 19, this is 22, and 24. Good. So the probability that a family has 3 children. So how many of the family has 3 children? Let me call that NA. How many family has 3 children? 3 children is 4. So your NA is equal to 4. So that means the probability of A now is going to be 4 over 24 all over the total families, all the families. And that is the same thing as 1 over 6. Now the B part says, what is the probability that a family has at least 2 children? When you hear at least 2 children, it means from 2 children upwards. That means 2, 3, 4, 5, and so on and so forth. So in that case, come back here. Probability of having 2 children. This is 2 children. We have 7 families have 2 children. So they said the least should be 2. So that means from 2 upwards for 2, 3, 4, and 5. So your answer is going to be 7 plus 4 plus 3 plus 2 all over 24. Okay, so 7 plus 4, 11 plus 3, 14, 14 plus 2, 16 over 24, which is the same thing as 2 over 3. So we can say that the probability of having at least 2 children is equal to 2 over 23. Okay, now that is awesome. So that moves us to the next topic, which is types of events. Now in probability, for our level, we are going to be looking at types of events. Now for our level, there are 3 types of events here. You have the mutually exclusive events. What are mutually exclusive events? These are events that cannot happen at the same time. So when 2 events cannot happen at the same time, it is a mutually exclusive event. If 2 persons are competing for a race and only one person can win, that's a mutually exclusive event, meaning that it is either A wins or B wins. So the probability of A or B is equal to probability of A plus probability of B. So or there signifies either. Independent events. These are events that can happen at the same time. They don't depend on each other. For example, when 2 people write exams, the both of them can pass. They are independent. That means each person is not dependent on each other. So, and here we use and to represent that. So probability of A and B is equal to probability of A times probability of B. We're going to be seeing the different types of independent events. When I pick, when I have a bag of balls, different colors of balls, and I need to pick a particular ball or 2 or 3 balls, so that's an independent event. Okay. Now, in addition, probability, where mutually exclusive event is derived from, the probability of A or B is actually equal to probability of A plus probability of B minus probability of A intersection B. Okay, this is actually the formula for probability of A or B. It is when nothing is common between the 2 events, that's when this becomes 0 and it is reduced to mutually exclusive events. That means for mutually exclusive events, probability of A intersection B must be equal to 0. That means nothing is common. Intersection means what is common. Union means to add. Okay, now let's see an example here. It says the probability that Ade passes an exam is 1 over 2. And the probability that Bose passes the same exam is 1 over 3. What is the probability that they both pass the exam? So let's look at this. Probability that Ade passed the exam, let me call that PA, is 1 over 2. Probability that Bose passed the same exam, that means PB, let's call that also 1 over 3. Now A says what's the probability that they both pass the exam? Okay, they both pass the exam. That means we are looking for the probability of A and B. Both of them pass the exams. And what is that? That means probability of A times probability of B. Probability that A is 1 over 2, probability of B is 1 over 3, so that gives us 1 over 6. That's awesome. Okay, the second question we're asked to find is that to find the probability that Ade or Bose pass the exams. Now, whenever you see a question like that, that's total probability. when we are given probability of Ade or Bosse pass the exams, what does that mean? That is equal to the probability of A plus the probability of B plus the probability of A intersection B. Never forget that. Never forget that. When you see two events like that, and the probability of A is 1 over 2, plus the probability of B is 1 over 3, then, sorry, this should be minus. This is minus. The minus probability of A intersection B is 1 over 6. So we can find the LCM here. The LCM is 6. 2 divided 6 is 3. 3 times 1 is 3 plus 3 divided 6 is 2. 2 times 1 is 2. Then minus 6 divided 6 is 1. 1 times 1, 1. Okay, so we have 3 plus 2, 5. 5 minus 1, 4, which is 4 over 6. Okay, that is equal to 2 over 3. Awesome. Now, that leads us to the last question, which is the C part. It says, what is the probability that only one passed the exams? What is the probability that only one passed the exams? If only one passed the exams, we can say that it is either Ade passed and Bosse failed, or Ade failed and Bosse passed. That's what that means. Ade passed, Bosse failed, or Ade failed, Bosse passed. If only one, don't forget. Okay, so that means probability of A times probability of B complement, or probability of A complement times probability of B. And that's substituting values now. Probability of A is 1 over 2. Probability of B complement means failed. So 1 minus 1 over 3. Then or means plus. Probability of A complement, which is 1 minus 1 over 2, times probability of B, which is 1 over 3. Which, if we continue, this is going to be equal to 1 over 2 times 2 over 3 plus 1 over 2 times 1 over 3. Okay, this is going to give us 2 over 6 plus 1 over 6, which is equal to 3 over 6, and 3 over 6 is 1 over 2. Okay, that is awesome. Now, let's see the next aspect of probability, which is coin throw. Coin throw. Now, when we throw a coin has only two sides, which is either a head and a tail. And the probability that a head shows up after throwing a coin is 1 over 2. The same with the probability that the tail shows up is also 1 over 2. So the probability that the head shows up and the probability that the tail shows up are the same. Okay, for two coin throw, there are 4 possible events. You can have head-head, you can have head-tail, you can have tail-head, and you can have tail-tail. So there are 4 possible events. Such that if I'm asked that 2 coins are thrown, and what is the probability that 2 head shows up? You see, 2 head, we just have 1 opportunity. It's going to be 1 over 4. If I'm asked what is the probability that a head and a tail shows up, a head and a tail, this is head tail and this is tail head. So a head and a tail, and that will give me 2 over 4, and so on and so forth. Okay. Now, just note that in multiple coin throw, the total number of possible events is 2 raised to the power of n for a multiple coin throw. So if I have 1 coin, the total, that's 2 raised to the power 1, which is 2. For 2 coins, 2 raised to the power 2, which is 4. For 3 coins, 2 raised to the power 3, which is 8, and so on and so forth. Okay, let's see an example here. A coin is thrown 3 times. What is the probability that A, only a head shows up, B, 2 head and 1 tail shows up, C, no head shows up? Okay, we need to know the total number of events. First of all, you should know that the sample space here for a coin throw is 2 raised to the power 3. which is equal to 8. So meaning that in this particular coin throw, we are going to have 8 different 8 possible outcomes. Okay, and what are they? Let's list them. It can be head, can be head, tail. It can be head, tail, head. It can be tail, head. It can be tail, head. It can be tail, head, tail. It can also be head, tail, and can also be tail. So you see there are 8 possible events there. So the probability for the first question says only a head shows up. That's just this. We have just one case like that. And the answer for A is 1/8. The second question says the probability that 2 head and 1 tail shows up. 2 head and 1 tail. Let's count. Here we have 2 head, 1 tail. That's 1. We have 2 head, 1 tail here. That's 2. We have 2 head and 1 tail here. That's 3. We have 3 possible cases there. So that's going to give us 3/8. And the last question says what's the probability that no head shows up? There are 2 ways we can solve that. Probability that no head shows up can be 1 minus 1/8. That means 1 minus only head shows up. And that's going to give us 7. Sorry, that's not true. Probability that no head shows up means that we have only tails. And we, in the case where we have only tails, it's just this. We just have one case here, which is 1/8. Thank you. So that moves us to the next.